Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 613. Please turn to it, page 613. Problem number 15 is what we're going to do. And today is our lesson number 60. Let's take a look at it. It says the length of the sides of a right triangle are 3 consecutive even integers. So we have a right triangle. Let's draw one for right triangle first. This is the right triangle, and we are told that its 3 sides are 3 consecutive even integers. And the length of the shortest side is x. So if this side is x, and since there are 3 consecutive even integers, how do we express the idea of a 3 consecutive even integers if the first one is x? Well, if the first one is x, the next one is going to be 2 more than that. For example, if the first one is 10, the next one is going to be 12, which is going to be 2 more than 10. It's x plus 2. It's 2 more than x. If this is 10, then this is x plus 2. The one after that is going to be 4 more than the first one. X plus 4. And those are our 3 sides. This is x plus 2. And our hypotenuse, which is the largest side facing the right angle, which is the largest side, is x plus 4. What is the question asking? Which of the following equations could be used to find x? Which of the following equation could be used to find x? Don't even bother looking at the equations there. Ask yourself, if you had to find x, if you were to ask to solve for x here, in other words, if you were asked to find out what are the 3 sides of this particular triangle, we'll have to solve for x. What concept would be employed here? The simple concept, the simple notion, the simple application that we need here is what is known as the Pythagorean theorem. Pythagorean theorem tells us that the square of the hypotenuse, which is x plus 4 here, the square of the hypotenuse has to equal the sum of the squares of the other 2 sides. So square of this side, which is x squared, plus the square of that side, which is x plus 2 squared, and that's it. I'm going to erase this x plus 2 because it's sort of getting in the way. So this is x plus 2, and that's it. That's our equation. That's it. We are done. The answer is C. This is the equation that you would use if you were asked to solve for x. If somebody were to ask you exactly what are the 3 sides, the numerical value of the 3 sides, or better yet, if somebody were to ask you what's the perimeter of this particular triangle, in order to find the perimeter of this particular triangle, we will have to first find out what x is. And this is the equation we will use. Answer is C. As a matter of fact, I'll do one better than that. I want you to actually find the perimeter for me. I'm giving you a bonus question. So we're going to add one more problem to it, one more aspect to it, one more facet to it. I want you to find the perimeter of this particular triangle. And once you have found the perimeter, once you have found the side x and then these 2 sides, once we have found all the 3 sides and figured out the perimeter, then at that point I want you to go and watch this particular video. Just type in math problems with the plural, math problems, day 28. Day 28. Just type in that part and you will see a video there that deals with the exact same question, except in that video you will find a solution to the question that I just asked you. The question is, what exactly is the perimeter of this triangle? Watch it after you have done the problem. Alright? Let's move on to the next one, number 16. Number 16. It says x is an integer greater than 1. So we have to keep that in mind. We are told that x is a whole number, it's an integer, and we are also told that it has to be more than 1. We are also told that y equals x plus 1 over x. The question simply is, which of the following must be true? There are 3 statements there. We're looking for all the statements that are true all the time. Not some of the time, but all the time. Well, simplest and the easiest way to tackle this problem, take care of this problem, is to plug in some value for x. We are told that x has to be an integer, it has to be a whole number, and we are told that it's got to be more than 1. So let's plug in 2. Let's pretend that x is 2. If x is 2, then y turns out to be 2.5, which of course is same as 5 over 2. Well, two things we notice here. First thing we notice is that y is not an integer. The second statement tells us that y is an integer. Second statement is false. Second statement tells us that y is an integer. Y clearly is not an integer because y is 5 over 2. So the correct answer, whatever it is, cannot have Roman numeral 2 in it. If you find an answer choice with Roman numeral 2 in it, we can kill it. A, B, C, D, and E. Do you find any answer choice which has 2 in it? C has 2 in it. C is no good because statement 2 says y is an integer. Y is 5 over 2, which is not an integer. Any other answer choice with 2 in it? E cannot be the right answer. Another thing we notice is that the first statement tells us that y does not equal x. Y does not equal x, which of course is true. Y can never equal x because x is some, let me use my pointer here. Okay, try to understand. X is some positive quantity. So 1 over x, no matter how large the x is, even if x happens to be a million, 1 over x is going to be some number there. It doesn't even have to be positive, as a matter of fact, now that I think about it. It's going to be x plus 1 over x. There is no way that x is going to be equal to y. There is no value that you can put there where x will equal to y. The first statement is also true because of the fact that it makes our life easier because of the fact that the x is positive integer more than 1. So you plug in 2, 3, 5, 10, whatever you put in, 5 plus 1 over 5 of course is not equal to 5. X does not equal to y. That statement is true, which means the correct answer, whatever it is, must contain 1 in it. So this is the opposite scenario. Before we were crossing out the answer choice, we crossed out C and E because it had 2 in it. Now we are going to cross out the answer choice, anything that does not have 1 in it. Anything that does not have 1 in it. B says 3 only. That's no good. Has no 1 in it. Answer is either A or D. What does D say? D says 1 and 3. Let's look at third statement, shall we? Let's look at third statement. In the third statement, we are told that x times y is more than x squared. Do you think this is going to be true? X times y is more than x squared. Well, there are two ways you can tackle this problem, tackle this situation here. One approach is to continue with what we have here, with the values that we have here, and do it out. For example, our x is equal to 2, so 2 times y, which is 5 over 2. 2 times 5 over 2, 2's are going to cancel out, and of course 5 is more than 2 squared, and that is true. Third statement is true. Third statement is true, therefore the answer is D. Another way we could have tackled this problem, another way we could have done this thing is to realize this part. Because of the fact that x is a positive quantity, the fact that it's a whole number more than 1 is not even the issue here. The point is simply is that because x is because we are told that x is an integer greater than 1, which means that whatever the hell it is positive. X is positive. Because x is a positive quantity, we can divide both sides of this inequality by x without having to worry about affecting the direction of the inequality. If we divide both sides of the inequality by x, what we find is that y is greater than x. This is what the third statement boils down to. Third statement boils down to the fact that y is greater than x. Is that going to be true all the time? Is that going to be true all the time? Answer is yes, because y equals x plus some positive quantity. This is some positive quantity. No matter how small it is, even if x happens to be a million plus 1 over a million is going to be very close to 0, but it doesn't matter. It's some positive quantity. It is 1 over x is always going to be some positive quantity, no matter how small. Even if x happens to be 30 billion, y would equal 30 billion plus 1 over 30 billion, which is some positive quantity. Therefore, x plus some positive quantity, of course, y is going to be more than x. Which is exactly what the statement number 3 says, incognito, in disguise. Oh, the word incognito is still here. Incognito is the word that I just used, which means in disguise. We learned that word on day number 42 in our vocabulary lesson, incognito, in disguise. That's what statement number 3 says, in disguise. When they tell you that x times y is greater than x squared, if you divide both sides by x, what we find out is that statement number 3 says, statement number 3 claims that y is more than x, which of course is true, because y is x plus some positive quantity. So it's going to be more than x. That's it. That's the end of our exam number 4. Today was our lesson number 60. I was looking at the blackboard because the day number tells me where we are. Each exam takes me 15 days, 15 videos. There are 3 sections in each exam, and it takes 5 videos to do one section. And there are 3 sections in each exam. So 15 days takes care of one exam. Today being the 60th day tells me that today was the end of the exam number 4. Tomorrow we'll start our exam number 5, alright? There are 10 exams in this book. We'll go through all 10 of them. I'll see you tomorrow, okay? Bye now.